My name is Pedro Oliveira. I'm a Senior Solutions Architect at SpectroCloud. And today, I'll be talking to you about how we've helped Dentsply deploy thousands of edge devices to dental practices so that they can help dentists do their job effectively. And we'll go through that deeply, and as it was mentioned, if you guys have questions, please do post them, and we'll take them through the Q&A at the end as well. So, first and foremost, a bit of a trigger warning. Don't worry, there's nothing crazy. But if you have any issues with the dentist, maybe from your childhood, this might be the time that you want to look away. But if you are anything like me, when you look at this picture, your brain might be telling you how bad that tastes. I do remember when I did my braces when I was something like 12, and the dentist was trying to put that on me, and I was like, "Mom, please, I don't want to do this," and getting sick and everything because of the taste. So this is something that, fortunately, we have evolved from, and believe it or not, Kubernetes is helping. So Kubernetes does have a lot of practical needs in the field, and one of them is with Dentsply. So Dentsply is actually taking this away from dentists, and it's helping dentists, and more importantly, kids like me at the time that had that bad taste in their mouth as they were doing their checkups and their braces. So today, what we have effectively is this 3D reconstruction intraoral scan. So basically, the dentist is able to scan your whole mouth, and as they do, they will be able to build your braces or do any checkups and check for problems that you might have in your teeth. And what does that have to do with Kubernetes, you might wonder? So I'll tell you that with Dentsply, what these guys are doing is effectively running this application in the dental practices. And this is actually running on top of Kubernetes and utilizing GPUs so that when the dental scan goes across your mouth, it obviously can identify teeth and everything and reconstruct your entire teeth structure so that you can do things like braces, as I said before. So, very quickly, the way it works is they put it in your mouth, they scan it out, and this is streaming all that data onto Intel NUCs. So in this particular case, Dentsply is using Intel NUCs, and then all of that is processed and obviously displayed to the dentist. So before, we had the dentists and the patients going through it, right? It was hard. Patients didn't like it. Dentists had to deal with it, sometimes maybe even mop the floor because people would get sick. But for DevOps, there was nothing to be done. Now, with all this new technology, dentists are happy, people are happy. They don't get that taste in their mouth. But the DevOps engineers, maybe not so happy. So maybe they get the bad taste in their mouth this time. So what this means is, how can we run these applications in all these different dental practices? So just for your understanding and for scale and for perspective, Dentsply is rolling out this year about 3,000 of these devices to 3,000 different practices, and by the end of next year, it will be about 5,000. So as you're running this application on Kubernetes, at scale, a lot of things start to pop up. The first one is, I don't know about you, I don't know about your dentist, but my dentist doesn't know anything about kubectl commands, or SSH, or Linux commands, right? So if something goes wrong, then how do we fix it? So that's a very important part. The other part is, how do we install it? Right? So if we're rolling this out, do we have 3,000 different engineers, or maybe not even 3,000, maybe 100, but then what does your rolling out plan look like? And can you pay 100 engineers to go and do this at scale? So this actually drove a lot of issues from the Dentsply side. So these were the different challenges that we've identified, and some I've already mentioned. So the first one is around onboarding. Like I said, dentists and even anyone at the practice, they don't really have any IT skills. You don't want them to have IT skills. They're there to do what they're good at, which is treat people's teeth, not to know Kubernetes. The other one is one very important one, which if you are used at deploying Kubernetes in the data center, it's something that you don't really think about, is networking. Networking in different practices will have completely different topologies, different settings. We're talking about different IP addresses, different proxies, certificates, you name it. So how do you get above this? And most important of all, the customer expectation is that you plug and play. That's it. They don't want to have to deal with anything. They want to plug a device to the power, maybe plug the Ethernet cable, and that's it. No screens, no displays, no keyboards, nothing. Right? And then the second part is, as you can imagine, in healthcare, and specifically as well in dentistry, patients' data is very important. So being able to be sure that the patient's data is safely secure, all that sensitive data is safely secure. And of course, protection against the different vulnerabilities. And then once you've deployed everything, then it comes the rest. It comes the day two. Right? When CVEs are released, how do you do security patches? When you do upgrades and those upgrades potentially fail, how are you gonna mitigate that? And you definitely want to make sure that there's no drifting in the different. If you have 3,000 locations and you start having snowflakes, then as a DevOps team, you're really going to start having a very bad time. And last but not least, monitoring. So you want to make sure that you monitor every device, and if possible, you know about problems before the dentists or the practices do. Otherwise, you're going to have some very angry people at the phone, especially because, as you can imagine, these dentists, as they do their oral scans, all these different things that they do are quite expensive. So if they're not able to do them, they are losing money themselves. So as with anything, money comes attached to it. So how did we go about finding a solution that could fit into all the problems? So we actually worked with Dentsply to bring up the requirements based on their actual challenges. So the first one that we set out to do is everything has to be automated, right? So everything needs to go in. You have to be able to plug the box. Everything has to come up, plug and play. And the same goes for the upgrades. The second part is the networking. And that was actually quite a challenge, even for us, which we've been doing this for quite a while. If you guys have been playing with Kubernetes for a while, you know that Kubernetes doesn't like network changes at all. You build a Kubernetes cluster, the Kube-API server will attach to a host network. If you change that, your Kubernetes cluster breaks, right? For dentists, in this particular case, if you're shipping boxes to dentists and you want to test them first on a different network, because obviously you cannot mimic 3,000 different networks, how do you do that? Right? When you switch it off, turn it back on again on the other side, how do you deal with that? So those are the kind of things that we had to deal with. And then around the security piece, like we said, patients' data is very important, and making sure that nothing gets tampered with is the second part. Because as you can imagine, from building these devices, all the way to pre-staging, all the way to the dental practices, there's a lot that happens and a lot of hands that go in between. So anyone could try and tamper with those devices. So making sure that we have full disk encryption to secure the data, but also making sure that we have things like secure boot and boot measurements, so that if anyone tries to tamper with it, the device is fully locked and nothing. And we know for a fact that the device on the other side is fully compliant. And then over-the-air upgrades is again another very important requirement, because as we said, if we have 3,000 and then by next year 5,000 of these, when it comes to upgrading them, you can't really be going one by one over the practice. So you really want to do all of this remotely and securely and promptly, right? So if there's a kernel issue, if there's kernel CVEs, you really want to go ahead and patch those as quickly as possible. And from the maintenance perspective, it all kind of comes in between what I've said already, but automation. So making sure you go into those GitOps practices, making sure that you build your Terraforms, as I'm sure you are aware, but also being able to centrally monitor all of these different devices at scale. That's also something quite challenging. Okay, so how do we bring it all together with Pallet Edge? So as we were talking to Dentsply initially, we were telling them about effectively our stack. So Pallet Edge is built on top of Kairos. So Kairos is actually an open source project that we started and we are maintaining. So if you guys are interested, you can go and check it, kairos.io. And what Kairos does is allows you to basically create any immutable OS from any Linux distribution. So Kairos is effectively a Linux meta distribution. So your Ubuntu, your Red Hat, your Fedora, you name it, you'll be able to bring in your OS, make it immutable. And after that, Kairos will be able to then bootstrap Kubernetes with any distro that you'd want to use. So for example, in Dentsply case, they're using RKE2, but we support, of course, upstream Kubernetes, micro-K8s, K3s, you name it. So for us, distribution is not a problem from the Kubernetes perspective. So then we've added a few more commercial side products. So trusted boot and full disk encryption. So we are actually doing measured booting, full disk encryption, and all the trusted boot is injected into the operating system. So when you bootstrap the device, all of that is already done for you. You actually don't even need to go ahead and manage any of those keys because we will do that for you as well. And on top of that, the operating system is immutable, as I mentioned, and we have this concept of an A/B partition as well. So when you're pushing your upgrades, either for your Kubernetes upgrades or for your operating system upgrades, you also have a fail-safe mechanism that ensures that when you do an upgrade, if that upgrade fails, we will revert back to the last working solution as well. Which, again, at scale, that's very important. So you can automatically roll back, and we do that via our A/B partitioning mechanism. And this is, again, only possible because through Kairos and with Pallet Edge, all these operating systems are actually container images. And because of that, you're able to do automated operating system and Kubernetes upgrades, okay? And on top of the operating system, we also have a device management agent, and that agent effectively allows you to bootstrap the operating system, bootstrap the Kubernetes environment, and then once Kubernetes is up and running, you then have your cluster management agent, which basically then installs your entire Kubernetes cluster with your integrations, your applications, your configurations, your policies, everything in one place. And all of this then is centralized back to our management platform, which in Dentsply case, they are using a dedicated SaaS platform because of data considerations. But from Pallet's perspective or from SpectreCloud's perspective, this could be multi-tenant SaaS, could be self-hosted, could be air-gapped. It doesn't actually matter. And most importantly, for the Kubernetes piece, right? So once your device is actually ready to be used, you can then start building what we call a cluster profile, which basically defines the desired state of your cluster. Okay, so here you'll specify which operating system do you want, which Kubernetes distro do you want, CSI, CNI, and all the different integrations that you want to use as well. So Nginx, Argo CD, or Flux, or Prometheus and Grafana, Elastic, whatever you need, right? And all of this comes as a profile that is then reconciled as part of the cluster with that cluster management agent I was just talking about. So you can start building these desired states for all the different clusters. If you have 1,000 of them, you can just use a golden cluster profile, deploy it to 1,000, right? And then manage it that way, just as an example. Okay, so when it comes to device onboarding and data security, that was actually one of the biggest problems that we had to overcome with Dentsply. And here, this is basically the outcome of us working with Dentsply and figuring out how we could roll this out into the field for all of their different dental practices. So initially, and we'll take this step by step. Initially, what they have is they are bootstrapping. So we have an edge builder that basically builds effectively an ISO they can bootstrap a machine with, and that's for them. It's bootstrapped by their manufacturing of their devices, and then if they want, this can also be preloaded with all the different integrations that they have. So the operating system, the Kubernetes, and whatever else they have on top, and then this goes to a warehouse somewhere, right? Then what happens is when the dental practice is ready, this then goes from the warehouse onto the dental practice. And on the dental practice itself, the only thing they have to do is power on the device. And then they have a iOS app, right, that connects to the device via Bluetooth. And if the device requires any extra configurations, they are able to do it via mobile app. So this is effectively headless because there's nothing attached to the device. Other than, of course, a Bluetooth application. So if there's proxy considerations, certificates, static IPs that need to happen, all that kind of stuff, all of that happens here. Otherwise, the device, again, you power it on and it just works, okay? Once the device onboards onto Pallet, and by the way, from Pallet's perspective, this is one way you can register, what we call register your device. What you can also do is what we call auto-registration. So Dentsply, they don't want to do auto-registration because for them, that was a security concern. But we have a lot of other customers that use auto-registration, which means that as soon as the device powers on and it connects to our multi-tenant SaaS or their management, local management Pallet instance, then the device automatically registers and it's available to be used, okay? So in their case, they do it via Bluetooth, so they have an extra step because they chose to do that. And then, as you can imagine, they're not doing things via the UI because deploying 3,000 clusters via the UI, as much as you are a UI warrior, that will take quite some time. So they actually built all of this via Terraform. In actual fact, they're not only using Terraform to build their profile and deploy in their clusters, they're also using Terraform to provision all of their devices as well. Okay? And we'll go a little bit deeper into that in a few slides. And then once they trigger their Terraform plan, obviously everything goes and deploys, and they can manage all of that via that way as well. So some different key strategies that from Dentsply journey make sense for you to have in mind when it comes to edge. So obviously data encryption is very important, so both in transit and at rest. So full disk encryption for them was something that they really wanted to have from the get-go, and something that had to be very low overhead for them. So in our case, when it comes to full disk encryption and managing all those different encryption keys, we do that for them, and then they use that as part of their pipeline. Now, the other thing that we do with that is actually, because of our full disk encryption, boot measurements and everything, so we can also use, once you have secure boot enabled, you can also use some of those keys to then sign your image, your Docker images as well. So for example, because they're using NVIDIA GPU operator, they're actually using the NVIDIA GPU operator signed drivers. So they sign that before they install to make sure that everything is not tampered with. Then zero trust. As you can imagine, these things across all of these different offices, they love to grow legs. So every now and then, poof, they disappear. So you have to really make sure that even if they do disappear, nothing gets compromised. So for them, least privilege first and foremost, which then means that just as an example, they have SSH completely off. So there's no user from an operating system level. There's actually no user on that operating system level at all. So once the device goes, you can't even interact with the device anyway. And then obviously intrusion detection for them, so very important to make sure that if the device gets breached, and unfortunately if you guys have been around for a while, you'll know that eventually there's always breaches happening. So for them, it's also very important to find when that breach happened and patch it as quickly as possible. That's the most important part, right? Patch it as quickly as possible, and revoke any access that might have been granted through the breach, and rotate all those different keys as well. Okay, so maintaining the devices in the field, which is again something else that, as I was mentioning before, that is very, very important when you have such big scale, right? So, as I was saying earlier, Terraform and automation for them, absolutely first and foremost, right? So they're using automation to do all their deployments and pre-staging as well, and the operating system updates when it comes to the CVEs is also something that is super, super important. And again, they leverage all the GitOps and the Kubernetes deployment strategies. Again, something that is very important here is, like I mentioned before, all of these operating system images, they are container images, right? So they are actually managing their operating system the same way that they manage their container images, right? Because it's all under the same layer. And alerting and monitoring. They really want to centralize all their alerting, all their monitoring, to make sure that they can find all the different issues before their practices do. And they're now starting to implement some AI ML, as with anyone, right? They're starting to implement some AI and ML for anomaly detection as well, based on all of the different data that they receive from all these different devices. And this is what it looks like in Palette when you're deploying multiple clusters. So we have a NOC-style UI, as you can see here. And what Dentsply does, as you can see on the left-hand side, what they do is they actually use a lot of tag-based, very much a tag-based approach. So all of the different devices that they deploy, they all have tags attached to them. And as they do the different upgrades, and as they want to filter all these different things down, they are actually doing it via tags. So when they do an upgrade, they can use the tags to upgrade a specific location, for example, or specific practice as well. So it's not a all or nothing kind of rolling upgrade as well. And it gives you, more importantly, a unified view, right? So as an operator, you can come here and view everything that is there. So some of the lessons learned from all this entire journey. I would say that one of the most important ones, and this one is not on the slide, was around, as I said, the networking. And I know I go on and on and on about the networking, but this was actually a real pain. So one thing that we did to fix this pain was with Palette, we actually built a functionality for Edge that allows you to use a VXLAN overlay network. And this VXLAN overlay network basically allows any device to self-discover other devices on the same layer 2 network and create a VXLAN network between each other. And what this means is, when you create a cluster that is running on top of VXLAN network, basically running on top of a static IP address, the host network doesn't matter, because the VXLAN network is an overlay that stays the same. And as you change the different devices across different networks, it doesn't even matter. And this was actually very important even for them during our proof of concept, because what these guys wanted to do was start building these clusters at the office, and then they would go home and continue build whatever they needed to build on the cluster, and then go back to the office. And obviously their office network different from their home network, which is exactly the same as what happens in the field with the different devices across between the warehouse and the different practices. So that was definitely one of the key learnings, even for us, that we took out of this, was building that functionality so we can now help other customers and industries where this is also a big need. Specifically for Edge, this is quite important. Then some of the learnings, again, that goes into the Edge is harder than we thought. So the security was really one of the, again, also mind-blowing ones for us. So we had to make sure full disk encryption, secure boot, measured boot. This is all below Kubernetes, right? So making sure that you have all of this bootstrapped and working before you even bring Kubernetes. And then if you then want to use that with your container images on top of Kubernetes, that was some of the challenges that we went through, and we were able to figure out with Dentsply, as I mentioned. And remote troubleshooting, again, like I said, you don't want to be shipping, it's prohibitive to be shipping all these different devices, all these different field engineers to 3,000 different practices if things start to go wrong. So you must be able to do remote troubleshooting and to do remote patching as well. And one of the most important ones, something that has been said by Dentsply as well, very publicly, is the fact that technology is constantly changing. So they wanted to be able to try and use any kind of open source project as they go along, right? So obviously, initially they had a stack in mind, and when we were doing our proof of concept with them, we basically built their entire stack as they needed. But the fun part was, they wanted to use a lot, or they wanted to start trying out a few of other projects. And as you can see on the left-hand side, or on the right-hand side for you in this case, there's a lot of other projects in Kubernetes, as you all know. So these guys actually went ahead and then just started installing all these different integrations by themselves. So for them, not having any kind of vendor lock-in was also very important. Primarily because, as you guys know, you don't know the future. So if you then want to move out from one integration into another, you must be able to do that very nice and quickly. Okay, and with that, I would say that hopefully that didn't hurt. Hopefully that picture didn't bring any bad taste in your mouth just before lunch. And I hope you guys enjoyed. I hope I trickled or ticked your mind a little bit on some of your own use cases. We are in the booth just outside on the right-hand side, booth V6. So if you guys want to have a chat and see some of the demos that we have for Edge, or if you have any questions that you want to raise there as well, I'll be out there. My colleagues will be out there as well, so feel free to come and ask those questions. And once again, thank you very much for being here, and enjoy your lunch.
Thank you, Pedro. Just before you enjoy your lunch, we do have a few questions. I'll try and keep it quick, because I know people want the lunch.
Of course.
So how high is your failure rate for updates?
So I'll take this in steps, because I don't know if this is operating system updates or if you mean Kubernetes updates. So for operating system updates, the failure rate is actually fairly low, just because obviously you pre-stage everything. And even if in pre-stage you don't find the issue, when you roll it out to the field, the device is able to roll back automatically. For the Kubernetes side, the failure rate is, again, very low, because you can pre-stage everything with, like I said, a new cluster profile, make sure that it all works, and then everything is deterministic, right? Once you move that to a new cluster, everything is fine. So there's no failure rate there at all, actually.
Cool. Next one, can the SaaS platform for Pilot Edge also be operated and installed on-prem?
Yes, exactly. So it can be self-hosted, on-prem, or in the cloud, and it can also be air-gapped.
Great, even more secure. Is any of the data stored on the edge devices, or is it immediately transferred to a bucket somewhere? I think you also said, yeah, they're immutable.
Yeah, no, very, very good point. So if you want, you can use your own storage solution on the device. In the Dentsply case, they are using, for example, Longhorn to do some of that. Most of the data for them, for patients' data, is actually backed up to the cloud. So if they lose the device, they can quickly swap it. There's no issues. But there's, from Pilot's perspective, there's no data stored in that specific device. It's actually up to you which data you want to store on your persistent volumes. Yeah.
Cool. Awesome. I'll skip this one for now, but I'll go to this. Are these single node clusters in the clinic?
Yes, yes, they are. They are single node clusters. Most clinics, the ones that do low volume, they're single node. So if there's any issues, what they do is they just send via courier, like DHL, a new device. If there's a hardware failure, and they quickly swap them. But for bigger practices, like dental hospitals, they use multi-node clusters. But today, most of them are single node. Yeah.
Okay, this one I'll actually. So what does Pellet do? I'll say they've got a boot.
That's it.
I'm sure. Can you demo it?
Yes,
as your boot,
yes.
so you can demo it as your boot. I don't know if you want to give a quick, but I'd suggest you also go to the.
I think you guys just got to come to the booth and see it out, see it for yourselves.
Few more questions coming in.
Okay.
So what is running on these clusters? Why is Kubernetes used?
So what's running on the clusters is basically just an operating system and then a few agents from our side, both for OS-based agents and Kubernetes-based agents. Kubernetes is used because for Dentsply case, that's what they have all of their different microservices and containers that they want to deploy. Their application is containerized, and that's why obviously Kubernetes is used. And we are a Kubernetes-only shop, so that's why.
Yep. Is it a flavor of Kubernetes K3s or full?
So we are not. We are distro agnostic. So in this particular case, they can use RK2, they can use K3s, they can use upstream Kubernetes, and they can use microK if they wanted to as well. So any distribution.
Last one, just before lunch. As you're deploying Kubernetes when the device is installed on site, do you have requirements regarding site connectivity, bandwidth, etc.?
So that's a very good point. So networking connectivity is a requirement, but that requirement is set by Dentsply, not by us. So our bandwidth requirement is very low. So we have other customers, one of my other customers, these guys operate automated drones or flying robots, as they call them, in a field in remote Argentina picking up apples. So the bandwidth requirements are really low for us, so they can do it with a 3G network. But from Dentsply perspective, because obviously they are backing up some of that patient data onto the cloud, they have their own data requirements as well. But from our perspective, our minimum bandwidth is anything LTE and above, I would say.
Cool. Awesome. Thank you, Pedro. Really interesting. Edge is, I think, a big topic coming up. Thanks again to Pedro. One last round of applause, please.
Thank you, guys.